Okay, so one last scenario and one last protocol to secure your switches from attackers and from, you have so far heard about the term of man in the middle and the rogue attacker and etc. So this was talked about and discussed in the port security when someone plugs in his port and start his cable and starts doing whatever he wants to reach, make the network false or reach chaos. The other one was DHCP snooping. Someone wants to offer IP addresses and your generosity is not welcomed because we know your intentions. And the last one we will talk about is right now is one of the most trickiest, like maybe you'll like this most, which is the dynamic ARP inspection. And dynamic ARP inspection is in further or advanced studies or protocols regarding the ARP, which we haven't talked before about ARP, neither in chapter 4, chapter 2 or 3, I'm sorry. I haven't talked before about ARP because actually I didn't found it mentioned in the blueprints of Cisco in chapter 2 or 3. But because we have reached chapter 5 and the end of chapter 5, we need to study dynamic ARP inspection and its shortcutted for the DAI. I have written DAI below in here someplace. Yes, the dynamic ARP inspection is known as DAI. So the dynamic ARP inspection, before I start talk about, I need to talk about the ARP first. After that, we should talk about further studies about ARP, which are dynamic ARP inspection. ARP, which is the address resolution protocol, is some advanced step that switches do perform after the MAC learning. The first thing that we have talked about in chapter 2, the switches chapter, was MAC learning. And MAC learning was about yes. What MAC learning was about, to establish a new table this way, and there was a port and the MAC address that is learned from this port. So it was about binding port number 1 with its own MAC address, or the MAC address of the device, not the MAC address of the port, but the MAC address of the device that is connected to port number 1, or even multiple MAC addresses connected to port number one, because port number 1 maybe is connected to a switch. So the switch is connected to 10 other devices. In my switch, in my port, I will receive in port number 1 multiple MACs, or maybe one single MAC is enough. What the address resolution protocol do, and it is a protocol that is negotiated between switches and routers and PCs, etc., just like MAC learning, just like some other known protocols in the switches world. Also, it's another protocol like it's completing the database of switches, is that it will establish a third column in this table, and in this third column it will insert the IP address, the very specific IP address that is related with this MAC address. So if this MAC address mentioned here is the MAC address of, like, this is my switch that contains this table inside it, and in port number 101 it's connected to a computer, an end device. So in this table you will notice the MAC address besides 01. This MAC address is not the MAC address of 01, it's the MAC address of the device in the opposite, or to the opposite of 01. So it's the MAC address of this PC. What will ARP do is that it will further question, it will send an ARP request from the switch to the PC saying, hey, you have the MAC address of this number, please can you also share with me your IP address, this interface's IP address, okay, which is this interface. Now I have its MAC address, I need to know the IP address that's logically assigned to this interface by the engineer. You know that any computer in the world have an Ethernet adapter, and maybe it's here, this Ethernet adapter, and this, or Ethernet port, and this Ethernet port by default comes from the manufacturer with a MAC address. What you do as an engineer to make this PC gets into the network is to assign dynamically, statically, or using a DHCP, which is dynamically, an IP address. So the ARP, what it will do is that it will complete the entire information and image in this table, is that for this switch, switch number 1, port 01 is connected to a computer that has this MAC address, and at the same time it has this IP address. The big benefit of the ARP is that because from now on, when a PC sends a packet not a frame. When a computer sends a packet, and packets are layer 3 technologies, and what packets care about, or the first major thing that packets or switches and routers do look for packets once they receive the packet, is that the source and destination IP address that's written inside a packet. I'm planning on the next chapter to make this workspace much bigger. We will see it in chapter 6, I hope so. So when a switch first receives a packet, it will look for the first two fields, which are the destination IP address and the source IP address. Of course, by default, the source, or logically, the source IP address is the IP address of the PC trying to reach maybe this router, trying to reach its gateway, which is this router. So the source IP address will be my IP address, this computer's IP address, and the destination IP address will be this guy IP address, this interface's IP address. When a frames receives a packet, because packets actually are encapsulated inside a big frame, just in case you were wondering, when a switch receives a packet, it will say, I don't deal with IP addresses, I deal with MAC addresses. So it will look for the frame, the big frame that's containing this packet, and will say, for you as a frame, I understand only MACs. Someone wants to reach this destination IP address. I can't understand destination IP address. I do understand destination MAC address. So what is the destination MAC address that you desire to reach, so I can help you and forward your packet to this specific IP address or this specific device. Here comes the ARP of binding this IP address with this MAC address. So just in case you have an IP address, then you know its MAC address, and if in case you have a MAC address, then the ARP will let you know its IP address. So it's a vice versa for the ARP. Agreed. I hope that you have catched the idea so far, is that when this switch receives a frame or a packet, wants to reach this destination IP address, switch will not look about the destination IP address, it will look about the correct destination MAC address, and thus it will forward to this correct destination MAC address. So this is what the ARP does, the address resolution protocol does. This is only the idea, the big idea of the ARP. When a switch that is connected to a computer and a router has some missing information in its table, has no idea what's the MAC address of this router, and someone wants to go to this destination, like it wants to go to destination 191.10.10.10.1, so it will send a packet, and this packet is encapsulated inside a frame to switch number 1, asking, please would you forward me or make me reach, or forward me, actually it would be better, would you forward me to 10.10.10.1, which is my gateway. The switch will say, I don't care about your IP address, just give me the MAC address of this 10.10.10.1. The first thing it will do is that it will look to its ARP table, or actually I believe it will be bound within the MAC learning table, MAC address table. We'll check that, should check that in the lab. What it will see is that 10.10.10.1 as an IP address is not even mentioned here, because I have no idea about him, because I haven't contacted with him before, and thus I have no idea about its MAC address. So please ARP, help us by sending something to 10.10.10.1, but I don't know where 10.10.10.1 is. So what do you think the thing that, or what type of messages that will send a discovery for everyone? I believe you got bored of the discovery message so far, because it's always a broadcast message. So ARP is a broadcast message. The big disaster again. The catastrophe of broadcasts again. Just like every protocol, everything in switches are broadcasts. This is the big problem of switches. So anyway, what will ARP do is that, saying that you don't know who is 10.10.10.1, let me handle this. I will inform everyone on the planet that I want to reach 10.10.10.1. Please, if 10.10.10.1 heard my message, reply to me. And because it's a broadcast, it will be forwarded to everyone in the universe. big disaster as always. And just one of them will be forwarded, of course, to this interface. This interface is already configured for 10.10.10.1, questioning or requesting who is 10.10.10.1. This one will reply it's me and will send an ARP reply to the switch. In this ARP reply there will be a source MAC address, you see, because it was sent from this source, which is this guy. So 10.10.10.1 just sent to us an ARP reply, and inside this ARP reply there will be the source MAC address of this device mentioned. I'm sorry. So this is how the ARP makes use of this broadcast message to go to everyone, and once someone replies to me that it's me you are calling for, it will reply with its source MAC address, which is the MAC address of this router, and thus I will take it, copy it and paste it, or I will take a note, or I will, how do you see it, register it, no it's not register, assign it maybe, or add it, or complete my field, my MAC address field in the ARP table. So this is how I complete my ARP table, just in case it was missing or incomplete. And this is also done by ARP. So it's done by building the table and also by completing it. In the future I'm making use of it at any time. So this is all the idea that you need to know about ARP. But what happens is that this broadcast message that is sent to everyone saying that I want to go to 10.10.10.1 can be manipulated or stolen, just like DHCP. You remember DHCP has snooping. What happened is this, in that scenario is that someone stole your DHCP request message and complained that it's me you are looking for. So I will give you the DHCP offer, and there is a DHCP packet also for you, and that's it. Now we are friends, and now I'm your gateway of using DHCP. Just in case you wasn't using DHCP, maybe a static IP address or any other types of addressing, what will happen is that for the first time that you want to contact your gateway, the broadcast message will go to anyone, to everyone, I'm sorry, just like every time connected to this switch that is connected to the router. Again, someone will attach its router and will assign to himself the same IP address. You see, he is someone from our organization because he knows the IP address of the gateway. Okay, so he will assign to himself this one, and this is not the big problem until now so far, because the big problem is yet to come, which is when I will send something to my gateway, and I know my gateway previously. This switch, when it wants to send the broadcast message to an ARP, it will send it to this guy and this one, and maybe for some reason this guy is closest to you, he will say that it's me 10.10.10.1 and will reply back to the switch saying that it's me and my source MAC address is this number. So the switch will record this number in the table, and starting from now on, whenever you send something to your gateway, the switch will say, your gateway, I don't care about its IP address, I care only about its MAC address, and its MAC address for me is to go through port like 03. You see, now we are hacked, we are manipulated. So this is what happens when someone wants to hack you. Dynamic ARP inspection. Now we need come to talk after like 12 minutes, 40 minutes. Oh god, I've been talking for so many 40 minutes as an introduction, but we are almost finished anyway. So when it comes to DAI or dynamic ARP inspection, this is like just like the HCP snooping. A broadcast message caused blah blah blah, like big mouth, like the switch made it a big mouth, talking everything to everyone. And the DHCP snooping before, just like dynamic ARP inspection right now, will assign or will limit only some certain ports as trusted ports, and only those ports are allowed to forward and receive broadcast messages, so that this specific broadcast message that caused this hacker guy to know who we are and to respond to us will make his interface untrusted, and thus he will not be able to reach us, and he will not be able to know or to take a copy or maybe to claim the first broadcast message to himself. So we come here to the broadcast message, to the dynamic ARP inspection, and someone might manipulate you and claim that he is the gateway. And this is also a man-in-the-middle attack. Again, this is another type or another scenario of man-in-the-middle attack. DAI will allow only trusted interface to receive and forward broadcast again, and this is done by cooperating with the DHCP snooping binding database. Because in DHCP snooping binding database, only the trusted and real gateway are assigned there and know who they are, along with their MAC addresses. So when you enable DAI and the switch, it will ask DHCP snooping first who is the trusted gateway and at which interface, to know also which MAC address is correct, so that whatever other guy claims that he is 10.10.10.1 coming from another port or from another source MAC address, I will not listen to him and I will not accept his offer for the broadcast, okay, for the broadcast message. So after inspecting and after knowing that this guy is faking the gateway, the ARP will either forward the ARP, the switch will either forward the ARP if this one is trusted and corrected according to the DHCP snooping database, or it will drop it. The switch will drop this reply from this ARP reply from this guy, from this hacker in here. And after dropping it, it will record it, it will log it in the switch. Okay, so this is all the idea, and this is actually a simple idea, just in case you get the DHCP snooping correctly and you understood it and make a good use of it actually, or you were able to lab it and understand DHCP snooping, then dynamic ARP inspection is not harder than DHCP snooping at all. Dynamic ARP inspection is about someone that's only replying to the ARP request with an ARP reply, a fake ARP reply, and I will make him stop at his place. I will not make him further sending the ARP reply. That's it. That's all we will do, and that's all you need to know about DAI. For configuration of dynamic ARP inspection, actually I thought we should implement dynamic ARP inspection, but all the materials or all the methods to implement dynamic ARP inspection, I don't think they are supported maybe on Backtracer, but mostly they are supported. But in any way, they are advanced studies, because we will need to assign some VLANs with some ARP access lists, etc. And this is beyond the scope of CCNA, of the new CCNA. Not even the old CCNA have the dynamic ARP inspection, and also doesn't to be implemented in a lab, and also to have studying the ARP access list. You remember access list in some couple of videos ago in this chapter, the same chapter, you had only to know the IP access list, and that's it, with its types, 3 types, and that's it. But knowing a MAC access list or an ARP access list is beyond the scope of this study. So we will not implement dynamic ARP inspection. For any curiosity, if anyone of you likes to implement it in the future for any further studies, it's okay, we can do that in a separated video beyond the scope of this playlist of this new CCNA exam course. And that's it. But one last notice to talk about, or one last thing to notice, is that static IPs do not use DHCP, and thus there will be no broadcast message. So what will happen is that the switch will drop the ARP, and this will be granted from a statically assigned IP address to its real gateway by trusting the port of the PC, or by creating the ARP access list that I have talked about. And in the ARP access list, you will create an access list that talks about ARP, and what does ARP do, what does ARP bind, is an IP address and MAC address. So you will create an access list, and in the access list you need to mention every host's IP address and MAC address at the same command line, so that you will give a clear image or a full image about describing or allowing or permitting such device in the access list by mentioning its IP address and its MAC address together, so it will be bound together using the ARP. So this is all you need to know about for now for the dynamic ARP inspection, just in case you wanted to implement it on the back tracer or in another emulator or simulator program. We will do that. It's okay, just request to me and we will do my best to do it after we finish the course. And if I suspected that Cisco might try to ask you about some practical sides of the dynamic ARP inspection, I will add immediately a new video regarding dynamic ARP inspection, and I will put the link in the description of this video, the link to the new video. But mostly, maybe more than 90%, you will not need to know the practical side of dynamic ARP inspection. So that's it. This is all you need to know about dynamic ARP inspection. This is maybe video number 68. We are almost one video away from finishing chapter 5 finally. I never thought that chapter 5 would take this much of studying and implementing it. So I thought it was a really simple chapter regarding a new field of security or network security for the CCNA exam. But we had to express all of that. We had to discuss all these theoretical and practical sides because this is what's written in the blueprints of Cisco. Anyway, just in case anything was clear in here, it's okay. We can proceed to the upcoming video of AAA, the last video in chapter 5. Just in case it wasn't, please comment down below in the video of our channel, and I'll do my best to reply to you and to answer your queries. So thank you for watching, and I hope you to have a good time and to see you in the upcoming video. Goodbye.